All right. So we have operations with radicals, and we're going to start with adding and subtracting. So you can only add and subtract like radicals. In other words, they must be exactly the same underneath the radical. Then just combine like terms. Okay, so what does that mean? So think about like when we combine like terms, right? Which is a vocab word. Right? It needed to be the same, right? So if we had 2x plus 3x plus 4, it would become 5x plus 4. We combine these like terms. Or 5x squared plus 3x squared minus 2x. This would be 8x squared minus 2x. So we couldn't combine these two because this had 2x's and this had an x. So it's very, very similar with radicals, except for it has to be the same thing underneath the radical, right? So if we look here, we see that this is the same as this, so we're allowed to combine these. So just think of this almost like an x, right? So we have 3 plus 2 is 5, and then we just make it 5 root 7, right? So you could think of like 3x plus 2x, where x equals root 7. We combine it to 5x, and then at the end we go back and we replace the x with the root 7. Okay, we're going to have to combine what we learned at the other radical lesson, which is simplifying it. So remember, we have this list of, there's two methods, right? We could take out perfect squares, right? Let's put this here. Simplifying, 1, take out perfect squares. So for example, if I have square root of 50, I can rewrite that as square root of 25 times the square root of 2. This is a perfect square. And then the square root of 25 just becomes 5 root 2. Or factor tree and take out pairs. Right, so if I have a 50, I go to 2, 25, 5, and 5. This is a pair, so I get to pull it out. And then this is what's left over, right? 5 root 2. Okay, so let's just write the perfect squares over here. 1, 4, 9, 16, 25, 36, 7 times 7, 49, 8, 64, 81, 100. So if I go here, right, out of 48, I know I can pull out a 16. I can pull it out 3 times. So I do root 3 minus 4 root 3. Right, because this is the same thing as root 16 times root 3, and then that turns into a 4. So remember, this is like a little 1, so 1 minus 4 is negative 3 root 3. Okay, here we have this is the same as this, and that isn't, so we can combine these, and we have to leave that one alone. So we have 4 minus 1, we have 3 root 2 plus root 3. And then here we could take out a 9, so 9 times root 10 minus root 4 times root 10. This becomes a 3 root 10 minus 2 root 10. 3 minus 2 is 1. 1 root 10, which is just root 10. Root 10 can't be simplified, right? Even though we can break 10 into 2 and 5, we need a pair. So we need either another 2 or another 5. So we're just left with root 10. So there's a lot of different ways that you can simplify, just whatever feels the most comfortable to you, right? And you can know if you're doing it right by checking the answers. Okay, multiplying and dividing radicals. So we have the product property of radicals. We did this a little bit before, but the root of a times b is the same thing as root a times root b. Okay, so simplify the following radical expression using the product property. So this one, we're timesing, so be very careful, right? This is a time sign, so it's as if this is a negative, right? So it's not this minus this, it's this times this. So that's really tricky. So what we want to do is we want to multiply. So let's put this here. Multiply outer terms. So that's step 1. Step 2, multiply inner terms. And then 3, simplify. Right? Okay, so let's do step 1. We're going to multiply outer terms. So we have 2 times negative 4 equals negative 8. Multiply inner terms. Root 2 times root 6 is, right, root 2 times root 6 equals root 12. And then we simplify. Right, so we have negative 8 root 12. That's the same thing as negative 8 root 4 root 3, which is this turns into a 2. Negative 8 times 2 times root 3. So we get negative 16 root 3. And we can always check with our calculator, right? So we do negative 16 root 3 gives me negative 27.7. And then let's do 2 root 2 times negative 4 root 6. Same thing. So we know that we did it correctly. Okay, let's look at this one. So this one we actually have to use the distributive property first. Remember, this stuff always comes back and never goes away. So we're going to do 4 root 7 times 3 root 2 minus 4 root 7 times 2. This becomes 12 root 14 minus 8 root 2. For here, we can't take anything out. So this is actually the most simplified it could be. Okay, quotient rule is similar. It's saying that the square root of a over b is the same thing as square root of a over square root of b. Okay, simplify the following perfect squares. Okay, so this can be rewritten as square root of 16 over square root of 49. And then we know the square root of 16 is 4. We know the square root of 49 is 7. And we are done. All right, we can rewrite this as square root of 121 over square root of 25. This becomes 11. This becomes 5. And it's already simplified. So we are done. Okay. Rationalizing the denominator. Okay, this is a vocab term, right? Vocab. It is not appropriate to leave a radical in the denominator of a fraction. Multiply by a form of 1 to get it out, right? This is the identity property. Right? Get it out. Okay. Simplify the following expressions by rationalizing the denominator. This is best seen through examples, so let's just do an example. So we see a square root in the denominator. That should be a red alert. We don't want that. So we're going to multiply by a form of 1. We're going to multiply by root 11 over root 11, right? And so then we multiply across, so we get 3 root 11 over root 11 times root 11 is just 11, right? And this is the most simplified it can be, so we are done. Okay, here we have root 4 over root 4. We multiply across. 1 times root 4 is root 4. Root 4 times root 4 is root 16. And then we can simplify this to 2 and this to 4. We can simplify that to 1/2. Okay, so this was actually the long way of doing it. Something that you could have noticed at the very first step is this root 4, you could automatically simplify that to 1/2. So you actually could have just seen like, oh, 1/2, right? So there's multiple ways of solving problems in math. The trick is to know which one is the most efficient. We don't want to waste time, but we also want to do it correctly, right? So if this is easier for you and you get down to the correct answer, that's good. You just got to worry about your time management skills. Okay, so first we're going to do the quotient property of radicals, right? This equals root 8 over root 5. And then we're going to multiply by root 5 over root 5, the identity property of 1, because we need to get rid of this radical on the bottom. Root 8 times root 5, now we're using the product property, is the same thing as root 40 over 5. And then this one we can rewrite as root 4 times root 10 over 5, which becomes 2 root 10 over 5. Okay, last one, right? We're going to rewrite it as root 12 over root 6. We multiply by 1 using the identity property of 1. We get root 72 over 6. Root 72, what could that be? Let's do the tree over here because I don't know off the top of my head, right? 2 and 36, and then 6 and 6, right? So here's our pair. So we get 6 root 2 over 6, which is just the same thing as root 2. This one was also a trick question, because if we'd gone back here, we could have seen 12 divided by 6 is just root 2. So we could have just skipped all that. But again, this is just to show you that the math works. We want to be able to rationalize the denominator along with doing all the other operations that we've learned. All right, a few more examples. You can try and pause the video if you'd like, and then come back and check. But otherwise, I'm going to go through them right now. So we need to simplify. So we're going to need a common denominator. Let's simplify each term, right? So we have 28. We get 2 and 14, 2 and 7. We get this pair of 2. So we get 3 root 7 minus 2 times 2 root 7, right? Because we pulled out the 2, plus root 9 times root 7. So this is 3 root 7 minus 4 root 7 plus 3 root 7. So 3 minus 4 is negative 1, plus 3 is 2 root 7. And again, I want you to get used to checking, especially on tests when you have time. It's most important to get through all the questions, but when you have time, you want to go back and check. It's a very good skill to have, right? So we have 3 root 7 minus 2 root 28. Whoops. Okay, be careful with the calculator so you don't type it wrong like me. 3 root 7 minus 2 root 28, right? We want to be in a new radical, plus root 63. And then let's try 2 root 7. Cool, same thing, we know we did it correctly. Okay. This one's tricky. This one we haven't really gone over FOIL before, except for in vocab, but this is like FOIL or double distribution. Or box method. So we'll go over an official lesson on this, but you should have learned it before, and it is a vocab term. So we don't want to just square each term. We need to write it out and multiply it properly. So we're going to write 3 root 3 minus 2 root 2 times 3 root 3 minus 2 root 2. And then we are going to FOIL it. So, right, let's do first, outside, inside, last. So first we have, I'm going to write it over here, right? First we have 3 root 3 times 3 root 3. Outside we have 3 root 3 times negative 2 root 2. Inside we have negative 2 root 2 times 3 root 3. And last we have negative 2 root 2, negative 2 root 2. Right, so this equals 9 root 9, negative 6 root 6, negative 6 root 6, and 4 root 4. Right, because negative times a negative is a positive. So we simplify that, we get 9 times 3, negative 6 root 6. These are already all simplified. And then we get 4 times 2. So we have to add these all up, right? I'm sort of doing FOIL in a weird way, but same thing. So we have 12 minus 6 root 6 minus 6 root 6 plus 8. So we get 20 minus 12 root, oop, that's a 6. 12 root 6. So let's double check. So we have 3 root 3, whoops. So tricky. Make sure you push right so that you get outside of that. Minus 2. Let's see if I can make this brighter. No, it's not that much better. 2 root 2 squared. And then 20 minus 12 root 6. Oh, okay, so I messed up somewhere. So, oh, that's 27, not 12. 27. So 27 plus 8 is 35. There we go. Awesome. 35 minus 12 root 6. Okay. Over here, we have 2 root 5 plus, you can pull out a 4. Root 2 root 3 minus root 9 root 3. So 2 root 5 plus 2 root 3 minus 3 root 3. These are our like terms. So you have 2 root 5. Positive 2 minus 3 is negative 1. Negative 1 root 3. Let's double check. 2 root 5 plus root 12 minus root 27 and then 2 root 5 minus root 3. Yay. Okay. Last one, another FOIL. So I'm just going to do the FOIL out here, right? Well, I'll write it out and then we'll do FOIL. Okay, so first would be 16 times 5. Outside would be minus 12 root 10. Inside would be minus 12 root 10. And then last would be plus 9 times 2. So this would be 80 minus 24 root 10 plus 18. So we get 98 minus 24 root 10. Okay, let's double check. 4 root 5 minus 3 root 2, all squared. 98 minus 24 root 10. Yay, okay. Cool, so make sure you're double checking. Just think of radicals as like variables. You need to combine like terms, and then you have to get really comfortable with simplifying radicals.